All right, today we're going to start Chapter 9, which is on parametric equations. In Chapter 9, we'll also study a little bit about polar and conic sections and a few other little things. Okay, first, kind of just to explain what parametric is it's a different way of writing your equations for a graph. What parametric basically allows you to do is, instead of having one equation, like y equals 3x plus 2, okay, like a line, you can have two equations. Okay? You can have one equation that basically controls what happens to all the x coordinates, and a separate equation that controls what happens to the y coordinates. So it gives you more flexibility, because you can have two different equations. And you can get all kinds of different graphs. Notice every one of these fails the vertical line test. None of them are functions. So if you were to try to sketch these, it would be pretty difficult on the calculator. Okay, using function notation, y equals something. But in parametric, not too bad. We'll look at some interesting ones. We'll look at one kind of like this last one on the right, except we're going to turn it and kind of squish it together a little bit. But we'll look at some different examples. All right, so we're going to start off with two functions, okay? Function f, function g. And these functions are going to be defined over a certain interval. Okay, I'll explain what that means. I'll explain how you put that in on your calculator, that interval. Basically, what's going to happen is function f is going to control the behavior of all the x values. Function g is going to control the behavior of all the y values. And they don't have to be called f and g. Those are just the two letters I picked. Okay, if you take all the ordered pairs you could get over this interval, okay, which they'll give you numbers. They might say your interval is from 0 to 2. Okay, those are the values you're allowed to plug in. You take all the points that you could plug in between 0 and 2, you graph them. The picture is called a curve. Our book refers to anything you draw parametrically as a curve. Even if it's a straight segment, they call it a parametric curve. So the two equations that we're going to use, we're going to have one for the x values, we're going to have a separate one for the y values. These are called parametric equations. Parametric equations always come in pairs. You have to have one equation that specifies what happens to x, one that what happens to y. If you're missing one, you wouldn't have anything to graph. You got to have two. And that variable that I'm using, t, that's called a parameter. T is allowed to take on any values within the interval. What's the interval? We'd have to look at a problem. Like, could be 0 to 2, could be 0 to 10, 0 to 360, negative 10 to positive 20. Interval could be anything. But t is only allowed to take on values that are within that interval. So let me show you what the screen looks like on the calculator. So if you turn your calculator on, okay, if somebody's already been using your calculator, it might already be in parametric mode. Okay, if not, if you press mode, okay, we've been using function all year. That's y equals and then a function of x. Well, if you go to the one to the right of it, that's parametric. Click on parametric. Press y equals, and now you see two equations per graph. Okay? One for x, one for y. Okay? You have to specify both in order to get a picture on the screen. Okay, a few other things that are different. When you press the button that says xt theta, before it used to give you an x, well now it's going to give you a t, because you're in parametric. Okay, but that's how you get t. Just press the button right next to alpha. Below mode. If you go to window, okay, you're going to notice a few things that are different. You still have x min and max, y min and max, the scale, which we won't play with this whole class. But you have this t min and t max. Well, t is the parameter. The minimum and maximum value for that parameter, that's the interval. So if they tell you the interval is 0 to 10, this is where you would type it in. Tmin is the lower end of the interval. Tmax is the upper end. And T-step, I'll explain more about that when we do some sketches. Right, so now kind of another way of saying the same thing we just said. If you have a curve defined by a pair of parametric equations, we say that these equations give a parametrization of the curve. They give a parametrization of the curve. As you saw in the previous screen, all the graphs I showed you, the curves intersected themselves. That never happens with a function. What test does a function have to pass, or does a graph have to pass to be a function? Yep.
Vertical line.
The vertical line test. So if I start drawing some kind of curve, the only way that it can intersect itself is if it fails the vertical line test. There's no other way. I mean, if it's going to come back and cross itself, it's going to fail the vertical line test somewhere. All right, so in general, functions do not intersect themselves, but parametric graphs can. Okay, a parametric curve has a starting point and it has an ending point. Where it starts and stops is dependent on the parameter. All right, so suppose we had a parameter that was defined over the interval, or over the domain, from A to B. Okay, this closed interval from A to B, that is our interval that we are allowed to plug numbers in for. So if it was 0 to 5, you would be allowed to pick anything you want for the parameter as long as it's between 0 and 5. On the calculator, that would correspond to Tmin and Tmax. Right, so how do you find the endpoints of the curve? Well, you have a starting point for your interval, and you have an ending point. You have a function that gives you your x values and a function that gives you your y values. So what you do, take your equation that gives you the x values, plug in the starting point of the interval. What that's going to give you is the x value for where the curve starts. Okay? If you want to find the y value for where it starts, take where your interval starts, a, it'll be a number, plug that number into the function that gives you the y values, and that'll give you the y value for where this curve starts. So A controls everything about where the curve is going to start. B controls where it's going to stop. How do you find exactly where it stops? Well, take B, plug it into your equation for x. That'll give you the x value for where it stops. Take B, plug it into your equation for y. That'll give you the y value for where it stops. And it's important to know where the curve starts and stops. You'll see why when we do an example. Okay, so I'm going to keep that up while we look at our first example and see if we can figure out where the endpoints are of that parametric curve. Okay, so my equation for the x values is 1 minus 2t. Equation for the y values is 2 minus t. In this case, our domain for t, okay, our interval, is from 0 to 1. So t can only take on values between 0 and 1. Okay, James, in this interval, which number here is going to control where the curve starts?
0.
0. So we're going to take 0, we're going to plug it into both of these equations, and that'll tell us where we start. Let t equal 0. Okay, so we're going to have x of 0 equals 1 minus 2 times 0. And y of 0 equals 2 minus 0. We have to find both those values. Okay, Darren, what's x of 0? 1. Okay, Brianna, what's y of 0? 2. So this curve is going to start at the point 1, 2. Okay. And now we're going to figure out where the curve is going to end. Okay, so where is the curve going to end? Well, first you're going to figure out what value controls where it ends. Okay. That's the 1. Okay, so when t equals 1, we're going to plug that in. We'll figure out our x and y values, then we'll know the ending point of the curve. We don't know what's going to happen between the beginning and the end. Is this going to loop, or is it going to be a straight segment? We don't know. That's where the calculator will help us. All right, so find x of 1 and y of 1. Okay, x of 1. 1 minus 2 times 1. And then y of 1, 2 minus 1. Okay, so now x of 1, that's going to be 1 minus 2, or negative 1. Y of 1 is going to be 2 minus 1, or 1. So my curve is going to end at negative 1, 1. There's the start and the stop point for this curve. All right, so on your calculator, first thing, make sure you change to parametric mode. Okay, if you haven't already done so. Okay, type in, again, the way you get t is you just press the button that used to give you x. So it's 1 minus 2t. All right, so 1 minus 2t. Okay, and then y is 2 minus t. If you forget to type one of those in, it won't give you an error. It just won't graph anything. Now we got to set our window. Yep.
Does it have to be capital T?
What do you have, the Nspire?
Yeah.
I'm not sure if it does it differently, but on all of your calculators that are just the TI-83s and 4s, it will be capital.
Okay.
Yeah, I'll have to check on the Nspire. I'm not sure on that. But whatever button you were pressing to get X before, it's probably in the same area,
Okay.
I would hope. Okay, parameter is from 0 to 1. So T min is 0, T max is 1. Okay, T step. Okay, what T step is it basically controls how many points are you going to graph between 0 and 1 to get this picture. What this is going to do is it's going to let t equal 0, and then it's going to go up by 0.1s. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So basically you're going to graph 11 points, including the endpoints, to get the picture of this curve. All right. The smaller you make this number, the more points it's going to graph. Okay, now it's going to graph over 100 points. It's going to let t equal 0.01. It's going to plug it in, see what you get. 0.02, 0.03, 0.04. It's going to keep adding 0.01 till it gets all the way up to 1. What do you think would happen if you make your t step too small?
It'll take forever to graph.
It's going to take forever. If I hit graph on that, it's going to add 10, 100,000, 10,000s, 1/10,000th every time between 0 and 1. Okay, first of all, my screen can't even display that much detail. Okay, so there's no point in that. Generally, point 0.1 is pretty good. I would say if you graph 10 points and then it's going to connect them, it should look pretty good. Okay, let's go zoom 6. Did I set my I thought I typed in 0 to 1, didn't I? 0 to 1. And I thought I set that at 0.1. That was weird. Okay, let's try again. Okay, there's our graph. Okay, if you want to zoom in a little more, you can zoom in on it. But it's basically a segment. And that's it. And we can let's look at the start and end points and see if it makes sense. Right one, up two. Yep, there's one of them. Left one, up one. Left one, up one. Yep, there's the other point. So that's the start and stop points of that curve. In general, when you pick a value for t-step, try to pick one that it's divisible into the end point of the interval. If you pick something like 0.3, okay, what's going to happen now is it's going to graph 0, 0.3, 0.6, 0.9. Then the next one would be 1.2. 1.2 is beyond the end of the interval. So what happens is it's going to graph 0.9. You're not going to see the full graph. See how it stops on that endpoint a little bit before -1? It's because the t-step, you picked a number that wasn't divisible or doesn't go into the endpoint of the curve. It'd be even worse if you pick something like 0.6. Now it's going to graph 0, 0.6, and then the next one would be 1.2. So now you're losing a whole bunch of your curve. Okay. All right, any questions on that, the t-step? All right, so here's our graph. All right. Well, what I want to do now is I want to basically rewrite that graph. Okay, I want to rewrite it in slope-intercept form. And to do that, we need to eliminate the parameter. Okay, this is not always possible to do. Sometimes it's possible to do. But we're going to rewrite our equation. So when we're done, we're going to have y equals mx plus b. Because that's what this is. It's the equation of a line. So we're going to take our example. We're going to rewrite it. Okay, in order to rewrite it, what I want you to think about is systems of equations. This is something you do when you have a system. What's one method to solve a system? The method where you take one of the equations, you rewrite it, and you plug something into the other equation. What's that called? Yeah?
Substitution.
Substitution. Right? So what we're going to do is solve the equation x equals 1 minus 2t. Solve it for t. And then whatever you get, you're going to take and plug it into the other equation. And once we do that, we're going to get rid of t. All right, so bring the 1 to the other side. Divide everything by -2. And a trick, if you want to get rid of this negative from the denominator, if you switch the order of what's in the top and the bottom, that's going to create, basically what that does is creates an extra negative. So if we cancel out the negative on the bottom, it gets rid of it. It's just a trick for getting rid of a negative in a denominator. You could go through all the algebra and work it out yourself. Maybe just think of dividing x by -2 and dividing -1 by -2. It become positive. Think of it that way. Okay, so that's t. Now plug it in. Okay, we're going to get y equals 2 minus, and you know what? Let's divide each part here by 2. 1/2 minus 1/2 x. So it's 1/2 minus 1/2 x. So now y equals 2 minus 1/2 plus 1/2 x. And our last step, just rewrite it in y equals mx plus b. So it's 1/2 x. 2 take away 1/2 is 1.5. So it's y equals 1/2 x plus 1.5. Okay, so now we have a function in y equals mx plus b form. Now we've got to be careful. If I were to graph y equals 1/2 x plus 1.5, is that the picture I would get? Darren? Not quite, I mean, partially that's true, but what would happen if you draw 1/2 x plus 1.5? Yeah, it would just go forever. This would be a small part of the picture. All right. So if you want to draw this, what you have to remember is to limit your domain. Okay. What does the domain have to be limited to? We just figured that out in the last problem. Look at the starting and ending x values. Okay. What were they? 1 to -1. That's the domain of this curve when you rewrite it in y equals mx plus b. It's between 1 and -1. So we can do that on the calculator. We can tell the calculator to draw this only between 1 and -1. Okay? And you got to use parentheses. All right. So what I'm going to do is go back to function. And I already have it typed in. I've got 0.5x plus 1.5. But I only want to draw it when x is greater than -1 and x is less than +1. If you type that in, just like that, you've got to put parentheses around everything. You'll get the same graph we just had parametrically. I tried typing this in as a compound inequality. It didn't like it. I tried like -1 is less than or equal to x, less than or equal to 1. Didn't work. So you got to, at least I think you got to type it in separate. Okay, you could also type this in x is greater than or equal to -1 if you like to put the variable on the left. That's fine. Okay, then hit graph. And you'll notice we get the exact same curve we just had. Now it's tracing along the x-axis. That's because it doesn't know what to do when x is bigger than 1 or less than -1, so it just traces along the x-axis. And then it puts in the segment it should, and then it traces along the x-axis again. But that's as good as you can do. Okay, any question on that? Okay, so don't forget, make sure you restrict your domain when you rewrite it. Let's try another one. It says eliminate the perimeter. Okay, so we have to solve that top equation for t. Colby, what do you get when you solve that top equation for t?
What's T?
What's that?
What's T?
T is the right after the equal sign. Sorry. Maybe it looks like an E or something.
Yeah, but what's the value of T?
What's the value? We don't know. It's going to be an expression.
So just T minus 1?
That's what x equals, but I want to get t by itself. So I want that -1 on the other side.
Oh, x minus 1. Or,
How would you move a -1 to the other side?
yeah,
You'd add it. So it would become x
plus 1.
plus 1. So x plus 1 equals t. I'm going to plug that in right there. And that's going to eliminate the parameter. Don't worry about the interval yet. That's going to be important when you write your domain, but not yet. You have a little bit of space to write your domain, but that's the function. Y equals x plus 1 squared. What shape is that?
That's a parabola.
It's a parabola, and it's been shifted. Anyone remember how it's been shifted, this +1?
Not quite left.
Yeah, it's been shifted left 1. Very good. It's been shifted left 1. Now, if you just drew this, you'd get the full parabola. But the interval was only 0 to 3. 0 to 3 is not the domain here. 0 to 3 is the interval when you write it parametrically. We've rewritten it. Okay? If we're interested in the domain, Andy, what values are the domain? X's or Y's? I don't think you won't find that in your notes. That goes like chapter 1 or 2. Goes way back. You got a 50-50 shot.
X.
I'd go alphabetical. Yeah, X. Okay, your domains, those are your X values. Good. So all we care about is where do the X's start, where do they stop. 0 is going to control where they start. 3 is going to control where they stop. Okay. One of them might come out bigger than the other. We have to do it out and see. Let's find X of 0. When you fill in 0, you get -1. Okay, Cody, how about when I fill in 3 in the X function? What do I get?
You get 4. Oh, no. 2.
2. So our X's are between -1 and 2. That's the only part of the parabola you're sketching, between -1 and 2. Since they had a closed interval on the original, this is also a closed interval, so you could write it this way, or you could write it this way. Either way. Okay. Any questions on that? Now this is curved. All right, so that t-step starts to become more important. When you're drawing things that are curved, especially like a circle, if you don't have enough points when you're drawing a circle and you connect them, it's not going to look like a circle. It's going to look like a hexagon or something else. So when things start to curve, try to keep that t-step pretty small, but not small enough where you're graphing thousands of points, because your calculator is just going to freeze. And you do second, if you press second off, that should stop it if you get stuck. All right, so it's not always possible to eliminate the parameter. However, you can always go the other way. You can always take something that's not written parametrically and rewrite it parametrically, kind of using this trick right here. It's kind of a cheap way of doing it, but you could do it this way. Pick the simplest substitution you can for the first one. Just let x equal t. And then in your other equation, change all your variables to t's instead of x's. And you'll automatically get 2 equations, and they'll be in parametric form. Okay, so I'll show you an example. Okay, so let's say I asked you to rewrite that equation parametrically. Well, first thing you do is let x equal t, and let y equal, change all your x's to t's. Okay, so you get 3t to the 4th plus 7t cubed minus 8t squared plus 2. And that's a pair of parametric equations. It's kind of a cheap way to do it, but it works, right? Look what the first equation says. Change all your t's to x's. Well, if I do that in the equation below it, I'd end up exactly back with what I started with. I'm going to give you one in a second that's a little simpler, but it's I want to come up with 2 different ways to do it. We'll do it this way, but then I want to try a different way as well. Okay, any questions on that? All right, let's try another one. Let's try y equals, keep it pretty simple, 2x squared. Let's do 3x squared. Y equals 3x squared. Okay, I want to write it parametrically. Okay, doing it the simple way, what would my top equation be? Just let x equal what? Just let x equal t. And what would the bottom equation become? Yeah?
3x squared.
Well, now we have to write it in terms of t. So we got to have all t's on the right-hand side of that equal sign.
So 3t squared.
It'll be 3t squared. And you can always check it. Make the substitution it says at the top. Let x equal t. And if you change all your t's to x's in the bottom equation, you get what's in the top. Let's try a different way. Other than this basic way, coming up with other ways can be pretty hard. Let's just try one. Right? Anybody think they see a way we could do it? And sometimes it's helpful just to pick something for x of t, whatever you want, and then make it work. Right? Because you could give me almost anything for x of t, and I could make it work somehow. So let's try this. 3t. Now we're trying to think of something here with a t in it, so that when we solve it, we get the same equation. Right, so remember, this top equation, when you plug it into the bottom one, you're going to end up solving it for t. So right now it's this. You divide each side by 3. That's what you have to plug in for t. And when you plug that into the bottom one, I want to somehow end up with 3x squared. Well, in this bottom equation, we're definitely going to need something raised to the power of what? Emily?
2.
2. We're going to need something squared. Let's just try t squared. Okay, let's see if that works. When you fill in 1/3 x for t squared, you'd get this. Instead of t, you'd have 1/3 x squared. Well, when you square that out, you get 1/9 x squared. Not quite what we wanted. We wanted 3x squared, not 1/9. So I need to stick a number in front of t squared. What could I try, and it's a power of 3. What could I try sticking in front of t squared to make that come out? Yeah?
27.
Okay, let's try it. See what happens. All right, and now again, keeping that top equation the same, solve it for t. T is 1/3 x. Now let's fill it in. 27 times 1/3 x squared. And you get 27 times 1/9 x squared. And 9 goes into 27 3 times. 27 times 1/9 is 3x squared. So here's another pair of parametric equations that work. A little harder to come up with that. I think it's easier just to stick with the basic one. But you could graph either one of these and they would both be correct. There's an infinite number of answers to turn this into parametric form. But by far, the one on the left is the easiest. All right, next thing we're going to do is we're going to define a circle, okay, parametrically. To define a circle parametrically, you're going to look at the x coordinate and the y coordinate separate. Okay, so my goal is to figure out how far over do I go? How far up do I go? I could almost make this into what shape that we use a lot, this diagram. Yeah, let's make it into a triangle. This time, we normally let the angle be theta. Let's let the angle be t. Okay, the parameter is the thing that's changing. Well, when you change your location on the circle, you're changing your angle. That's the thing that's changing. Okay, so that's t. Let's let the hypotenuse be r, because that's the radius of the circle. The length of the bottom side is x, and the height of the triangle is y. Now we have to come up with a trig function. Let's start with one for x. What trig function would involve t, my angle, x, and r? Think about what side r is in the triangle. Think about what side x is. And there's only one trig function that has those two. Oh, Casey, remember what trig function? Or do you remember, what's the name of side r? Because it's across from the 90. Hypotenuse. So we need a trig function that has hypotenuse. And what's the name of the side that's right next to the angle? Adjacent. You want to remember which trig function has those two? Yep. Cosine. Good. So the cosine of my parameter, cosine of my angle, equals adjacent over hypotenuse. My goal, though, is to get x by itself. That's how you write it parametrically. X equals. Multiply both sides by r. Okay, there's an equation for x in terms of t. R will be a fixed value. It's a radius. They'll tell you what it is in the problem. T is going to be a variable. It'll change. And the equation for y is going to be almost the same thing, except we're going to use a different trig function. James, which trig function would involve opposite and hypotenuse?
Sine.
Sine. If you type this in on your calculator, pick a value for r, keep it the same in both, you'll get a circle. So if you want to draw a circle that has a radius of, say, 5 cosine t, 5 sine t. Those are your two parametric equations. All right. In fact, that's going to be our next one. I want to know what the equations would be for a circle. This is going to be centered at the origin with a radius of 2. Okay, what would be the equation for x if the circle is going to have a radius of 2? Oh, Colby? So you're using those two formulas from on the left-hand side. You can help her out. James?
2 cosine t.
And what about for y?
2 sine t.
2 sine t. Is there any questions on how he got that? So you're just taking the two equations we had and you just fill in what r is, in this case 2. Now, if you wanted to shift it up or down, you would add or subtract a number to which one of these equations, do you think? If you wanted to shift it up or down. Oh, Cole?
Sine.
Yeah, you'd add a number to sine. You'd say 2 sine t, you could put a plus 3 on the end of it or something. Okay, that would shift it up and down. If you wanted to shift left and right, you'd add plus or minus to the top equation. Okay, let's try to draw that. So if you're not in parametric, switch back to that. Okay, type in 2 cosine t, 2 sine t. Now this is a circle with radius of 2, centered at the origin. Let's start with our x min and max. I think that's pretty good. If the radius of this circle is 2, it's not going to go any more than 2 to the left or 2 to the right. I would do the same thing up and down. Right now it's going to go off the screen. So let's go negative 2.5, 2.5. Okay, next thing. Doesn't tell me what to set my parameter at. What do you think the parameter would have to go from what to get a full circle when I draw this? Think about the period for sine and cosine. And we're doing it in radians. We could switch to degrees, but yeah, 2 pi. If you go any less than 2 pi, you're not going to get a full circle. 2 pi is about 6.28. So if I hit enter right now, I only get part of a circle. Okay? If I want to get the whole thing, set your parameter to go from 0 to 2 pi. Now remember, your screen is wider than it is tall. So if you set the x min and max the same as the y min and max, it's going to distort the image. So it's going to look like an oval. But it really is going through 2 on each axis. If you want to make it look better, go zoom 5. Now it makes it look more square. And notice my parameter is set at 0.1. That's pretty good. Okay, to go from 0, we'll say about 0 to 6 by 0.1, that's a little over 60 points it's drawing. What would happen if I did this? Actually, we're going 0 to 2 pi. So let's type this in. 2 pi divided by 4. So now I'm going to graph the point 0, 1.57, 3.14, 4.71, and then back to 6.28, back to 0. What's the shape going to look like if I only draw 4 points? Yeah, it's going to look like a square. Okay, it only did 4 points, and it's going to connect them all. Okay, if you make it, as you lower the t-step, you get more and more points. It looks more like a circle. So if you did, say, 2 pi and divided by 8, now you're going to get 8 points to make up that circle. So it's looking more circular, but that's still not quite circular yet. All right, so again, 0.1, probably pretty good. Or 0.18, that's fine. That'll look circular. Okay, now it doesn't quite connect at the end. The reason is because I probably picked a number for t-step that's not divisible. So the last one might be like 6.2, and then the next one would be 6.38. So it's beyond the end. So my advice, pick something that's divisible or pretty close to the end point, and then it should look like it connects. Now, if you did 0 to 360, I wouldn't set your t-step at 0.1. It's going to graph over 3,600 points, and your calculator will freeze. So you have to stop it. If you're going 0 to 360, I would say maybe you could probably set your t-step at like 10. Then it would graph 36 points. That's probably good enough for the circle. Okay. So just by playing with the t-step, we can create all kinds of different equations with the same formulas. All right, so in example 4, the one we just did with the circle, the domain is -2 to 2, the range is -2 to 2, but the value for the parameter, or the domain for the parameter, was 0 to 2 pi. If you don't go to 2 pi, you won't get a full circle. What would happen if you go beyond 2 pi? What happens in the sine and cosine function if you go beyond 2 pi? Start getting in. It starts over. So let's say you go 0 to 4 pi. What's going to happen is this is going to draw the circle, and it's going to trace over itself. You might see it, you might not. Let's see. Yeah, you can see it. You can see it the second time because the values are slightly different when you're going out to like 8 or 9 decimal places. So the points look just a little different. Okay, but it traced over itself twice. In general, we try to draw a graph using the minimum parameter, the minimum interval you need to draw the full picture. Okay, let's try this one. X is going to be t cosine t. Y is going to be t sine t. This is kind of like the equation for a circle, except look what's in place of r. It's a variable, the parameter. So it's like a circle, except the radius can change. What shape would that be? If you have something that's kind of moving in a circular pattern, but the radius is getting bigger and bigger.
A cone.
Well, it's going to be a flat shape. It won't be 3D. It won't be 3D. Think about on paper if you had points that kept getting further and further away from the origin as you drew them, moving in a circular pattern. It's going to be a spiral, yeah. Okay, this is going to spiral. They're telling us basically to draw 2 revolutions of the spiral. Okay, 0 to 2 pi. 0 to 4 pi. So we already got that. Type in t cosine t, t sine t. You can see how similar it is to a circle. I didn't have to change very much. Now we also have to think about how big to set our domain. Since it's spiraling, we need a bigger window. So look at sine and cosine. James, what's the biggest that the cosine function ever hits?
1.
1. And the biggest value that t can hit is 4 pi. So 1 times 4 pi, that's about 12 and a half. So I'd say we should go at least up to 12 and a half. And Brianna, what's the smallest that cosine ever gets? 1 is the biggest. Does it go any lower than 0? Anyone remember that? How low does cosine go? Negative 1. Right, so negative 1 times the biggest t value you could ever have is 12.5. It's impossible to ever go below negative 12.5. And that's the same for sine, too. The biggest sine can get is 1 times 12 and a half and negative 12 and a half. Okay, so you really got to know those domains and ranges well for sine and cosine here. Okay, and we're going to go by 0.1s. That should be fine because we're only going to 12. So let's see what it looks like. It's a little slow, but not bad. And we fit it perfectly on the screen just like we wanted. Okay, so we get a spiral. Now we could try all kinds of things. We could change maybe the direction of the spiral. Maybe have it spiral in instead of out. You wouldn't know when you're looking at the final picture how it was drawn, but it's all kinds of things we could play with. Any question on that? All right, so all you'd want to do here is write down your x min, x max, y min, and y max. In fact, what I can do is go like this. Here's your values for example 5. That was 0. All right, let's take a look at example 6. So I'm going to type everything in, but before we even hit graph, there's a lot of stuff to think about in order to set our window. So we have 5 sine t for x. Not quite the equation of a circle. They put sine with x, so that's a little different. And then 5t cosine t for y. Okay, I'm going to set my parameters, 0 to 20.5. 0.1, that's fine. Okay, let's look at our x values. There's a limit on how big and small those x values can get. Think of how big sine can get and multiply that by 5. Think of how small sine can get and multiply that by 5. There's your left and right. Does anyone think they can tell me my x min and x max? Darren? Okay, what's the biggest sine can get? 1. Now multiply that by 5. 5. So there's no way that this x of t function is ever getting bigger than 5. Because you just gave me the biggest value it could ever be times 5 is 5. So it's going to be from 5 to, what's the lowest it would go? Negative what?
1.
All right, the lowest that sine could go is negative 1 times 5. Negative 5. So your x min and max is between negative 5 and 5. Y min and max is a little harder. You have a variable that's being multiplied. Anytime you put a variable in front, okay, that's going to cause it to grow as big or as small as you want. You're going to have to look at your interval. If t was a million, it'd be 5 times a million. It'd be 5 million times something between 1 and negative 1. Okay, so this could be very big. In our case, we're only going up to 20 and a half. Okay? So if you take 5 times 20 and a half, it's a little over 100. Times cosine can only be between 1 and negative 1. I would say go between negative 115, positive 115. Those would probably be good y values. There's no way it's going to go beyond that, not with this parameter. If the parameter got bigger, then it would. 5 times 20 and a half could get a lot bigger. All right, so let's try. Okay, well, I think we've got everything else typed in. Let's hit graph and see what we got. Could have made that left and right maybe just a hair bigger, but that's okay. All right, so we get this kind of like watermelon-looking shape. Okay, if the parameter kept going, it would just keep not spiraling, but expanding up and down. It would never expand more left and right. But what would happen is it gets higher and higher. You know, those curves would start to get sharper and sharper. You can see towards the origin, they're pretty flat, and then it starts curving more. Eventually, it would really be curving. Okay. Any question on that? Okay. So that's that one. And you know what? Let me get the window for that. Let's just move this down. Number 6 and number 7. All right, so number 7, we've got 5t minus 5 sine t. Okay, you've got a variable that's not in the trig function. Okay, that could get very, very big. Okay, we don't know how big. Depends on the parameter. Let's just try graphing this from 0 to 30. Right, just to give me a limit. So I know my x value, 5 times 30, that's 150, plus or minus 5. All right, 5 sine t can't get any bigger than 5, can't get any smaller than negative 5. All right, so let's set our x out to, that's 130, minus a minus could become a plus. So I think if we go to 140, we should be safe. Okay, x min. Well, it's never going to go, is it going to go? Nope, it can't go negative. Okay. Let's see, well, if t was 0, okay, you'd have 0 take away 5 times the sine of 0. Well, the sine of 0 is 1. So if it was 1, I'm sorry, sine of 0 is 0. So that would be 0 minus 0. So if t is 0, it's not going to be negative. It's going to start at 0. So let's start x min at 0. Okay, y. This is pretty limited. We can get 5. The highest it could ever go is if cosine came out to negative 1. Then it would be 5 minus 5 times negative 1, or 5 minus minus 5. So it would hit 10. But it can't go any bigger than 10. So let's set it up to 12. Set up to 12. So So that's our y max. Okay, how low could it go? Let's see. Well, if t is 0, cosine of 0 is 1. 1 times 5 is 5. 5 minus 5 is 0. So I don't think we're going to have to worry about negatives here. Even if cosine t came out to positive 1, that would be 5 times 1 is 5. 5, yeah, you're not going to have to worry about the negatives. Okay, so just set it to 0 and hit graph. Let me check my graph. All right, so something looks a little off. So we had 5t minus 5 sine t. Oh, did I not type it in? So 5t, 5 sine t. And the other one is 5 minus 5 cosine t. Make sure you type your equation in. Now hit graph. That looks better. All right, so we're getting this pattern where it's almost like something bouncing along, but it just keeps bouncing at the same height. All right, so I'd say that's good enough for a complete graph. Use those values. Well, this particular graph, the way it kind of bounced along like that, it has a special name. And it's called a cycloid. Okay, the name of that graph is a cycloid. Okay, if you factor out 5, okay, from our equations, you could write this as 5 times t minus 1 sine t, or just 5 times in parentheses t minus sine t. That would be equation for x. And if you factor a 5 out of the second part, you'd have 5 and then parenthesis 1 minus cosine t. All right, so we just graphed a cycloid where a was equal to 5, and it was distributed out. Okay, but that pattern, that's a cycloid. Now, if you take, let's see if we can get a picture of that. If you take one of these cycloids, okay, and reflect it, okay, over the x-axis. So let's make a copy of this. Okay, and I'm going to flip it like that. Now we've got these kind of U-shapes. Okay, something kind of on that idea. Well, if you had an object at this point, and you wanted it to reach this point by rolling down some kind of track, an inverted cycloid, okay, that shape, basically gives you what's called the curve of quickest descent. Meaning that if you have an object at the origin, okay, right here, and it's going to roll down that curve, there's no faster curve than a cycloid for it to roll down. I don't care what other ways you try to connect the origin to point P. If you draw a straight line, and you let the ball go and I let the ball go, the cycloid's going to hit it first. Okay, if you try to draw something like this, that curve won't be any faster than the cycloid. The cycloid will be faster. And again, that's called the curve of quickest descent. It's like an inverted cycloid. Okay, any questions on that? Okay, anybody have any questions kind of related to the calculator about how to graph some of these things, how to set up your window, your settings, anything like that? Okay, so that's a quick introduction to parametric equations. So it does take a little bit of practice to get used to doing it on the calculator and figure out your window, but I think with a little practice we'll be okay. All right, so the homework, it involves quite a bit of graphing on the calculator. Okay, so you will need one. And it's on page 481. It's 1 to 5. 7, 9 through 11. You know what? I think there's an easier way to say that. It's basically 1 through 17 odd. Yeah. It's 1 through 17 odd. And then 21, 22, 25, 26, and 29 to 33. Right, so we'll take a look at that tomorrow, then we'll go over any questions, and then we'll look at section 9.2, which we're going to split up into 2 days.